This is a lecture on 3-1, measures of central tendency, and we will start with the definitions. There's two definitions that I'd like you to keep in track. It's statistics and parameters. A statistic is a characteristic or measurement obtained by using the data values from a sample, and the parameter is the same thing except it is a population. So what we're going to do is every time you're collecting a raw data, if you're calculating this as if it was a sample, because you're taking a certain sample from the population, we're going to call this a statistic. It's going to have its symbols for labeling the mean, the standard deviation, and all the other stuff that we're going to talk about this semester. Now, a parameter it's the same measurement, but from the population. Now, if you go and ask every single person in a population, then you know that you have a population, let's say mean, average. But if you only take 10 people or 30 people or 100 people, it is now called a sample. So you cannot assume that you have talked to everybody. So what we do is we actually study samples, we collect and organize statistics, and what we do is we predict parameters. As in, we don't know what the population mean is, but from the sample, I can infer it, inference. So that will be the third portion of the semester. So this gets me to the mean. What is the mean? The mean is the average. You've seen this before. A sample mean has a symbol. So this lecture is in Word. Under Insert, what you have is you have a couple of tabs over here. One of them is the equation, and the other one is symbols. And I can move this. So if you push on the equation, what happens is you have a pop-up screen that allows you to type in anything you want, as in the equation of anything you want. A sample mean is denoted by an accent, so I'm going to push on accents, and what I'm looking for is I'm looking for a little dash. It's called a bar. If I go over with an arrow or click with my mouse and I push an X, I have, let me unhighlight this. I have the symbol for the sample mean. Notice if I click on this, this was created through equation editor. The little n is the sample size. Now, if I'm talking about a population mean, I'm going to use a different symbol. So the symbol for the population mean, I'm going to click on Insert, Equation. What I need to find a Greek letter mu. It will be under Basic Math, because Greek letters are under Basic Math. If you notice, it even has a subscript of what it's called. That's a mu. The only difference in the formulas is this one has a little n, which is a sample size of the size of the sample, and this guy has a large n, where n is the population size. So little n versus large n are actually slightly different notation. Now, a median is the midpoint of the data array. So if you put them all in order, the one that's exactly in the middle, that's called a median. Now, if you have even number of data points, you take the middle two and you take an average between the two. This is how you find a mean, but all of this is going to be done with our calculators. The mode is the value that occurs the most often. So the useful part about the mode, it's the highest bar. Okay, now I got this picture of different types of distributions. Now we've seen those in terms of histograms. Now I can easily pretend that this is a histogram by drawing these nice looking bars. But what I want you to do is I want you to realize whether you're talking about a histogram or a nice smooth curve, what we can do is we can actually jump between the two. So if you have enough of those bars, you can pretend to draw a smooth curve. So this one happens to be a normal symmetric bell-shaped distribution. What we notice is the mean, the median, and the mode is exactly in the same place. They're right in the middle. It's the highest, it's the tallest tower. It is exactly in the middle, and that's where the average, the arithmetic average, happens to be as well. Now, if you have negatively skewed or skewed to the left, that means that the tail is on the left-hand side. What you end up is this value, these really tiny values, they're going to pull the average over. It doesn't reflect on the mode because there's just not too many of those. It doesn't reflect on the median as much. It just pulls it a little bit. But the mean is the one that's affected the most. So what you see is you have the mode, the median, and the mean. So the mean is the smallest, then the median, and then the mode. Now, if you have a positively skewed distribution or skewed to the right, what you see is the opposite direction. The mode is to the left, then you get the median, and then the mean is the highest one because that large value that's way over there really pulled this mean away from the mode. So this is something to keep in track for 3-1.